And we are back. Thanks so much for watching. Where we left off last time was number 11, where we were talking about the y-intercept, get that from the standard form, and the x-intercepts from the factored form. So let's go to number 13 and 15. And let's see here. So I feel like for time's sake, we're not going to be able to do those, both of them. They both look pretty similar, don't they? But I'm going to give you some help, and then you could do the rest. You could do the rest. And so 13, you're going to factor it. And so remember, it factors into x and x. But what are factors of 12? Well, we got 1 and 12. 2 times what? 2 times 6. 3 times 4. 4 times 3. We just repeated, so that means we're done. So it's one of those that's going to add up to the middle term. So what's our middle term? It needs to add up to 8. Which one of these adds up to 8? Oh, is it 2 plus 6? Yeah, 2 plus 6 adds up to 8. Good, so that's our factored form. That's our factored form. And so now, can you use the factored form to find the x-intercepts and y-intercepts? Well, to find the y-intercepts, you're going to have to multiply the n term. Remember, that's the c value. And that's 2 times 6. What's 2 times 6? 12. So we're going to go 0 up 12. The x-intercept comes from taking each of these and setting them equal to 0. Setting them equal to 0, setting them equal to 0. So I'll let you finish that. So that's going to be x equals negative 2, but really you want negative 2, 0. And what's the other one? What's the other one? Minus 6 to the other side, x equals negative 6. Newbold, you're doing the whole thing. Okay, I'll stop. So is there a vertical stretch there? Just keep going, Newbold. You're on. Okay, keep on going. Pause me, though. Try it on your own. Is there a vertical stretch? No, there's not really a vertical stretch there. It is going concave up, though. Did we say the other one was going concave up? I hope so, yeah. Okay, good. So this one you're also going to factor, do the exact same thing. But I'd pull out a GCF first. What do they have in common? Pause me. Try it on your own. So it is a 2. We can pull out a 2. Right? And so when we pull out a 2, we're left with x squared plus 2x minus 3. Good. Can you factor that more into factored form? What are factors of 3? 3 and 1. Side of middle term goes with the bigger number. So we do have a stretch going on. We do have a vertical stretch of narrower. Okay, so I'll let you finish that one. Right? Watch out for number 14. Because number 14 is going down. So I guess you could say a vertical stretch. Not really. But the vertical stretch... Here, let me just take a look for a second, because I was worried about that one. Yeah, I was worried about number 14. So we do have we don't have a vertical stretch, but we are going down because the negative, right? Yeah, because the negative we're going down. But still, go ahead and factor that. Go ahead and factor that guy. That's going to be a little tricky, isn't it? Because the negative, I didn't think about that. Interesting. So how could we look at that? You could change all the signs if you wanted to factor it, right? So if we're trying to find factored form, I would probably change the signs. And so I would go ahead and divide, well, I don't want to say that. Well, yeah, because you're technically setting y equal to find the x-intercepts, you're setting y equal to 0, and this is our y value. So 0 equals negative x squared minus x plus 30. And so if you think about it, it's hard to factor with a negative. So I would just change all the signs by dividing. You have to do it all 3 terms. So I would go ahead and pull out a negative 1 there. And so we'll pull out a negative 1. And so then when we do that, oh yeah, there we go. So when we pull out a negative 1, so then we get x squared plus x minus 30. Way-o! And so that can factor more now. That can factor more. And so we do have a new function there that's still concavity down and stretch none. That'll help you factor in a factored form and get the x-intercepts. And then the y-intercept, way-oh! Okay, so keep on working through those, good. Number 15, keep working through that. Did you figure it out? So it is a 1 and a 3, factors of 3. Sign of the middle term goes with a bigger number, good. This is a vertical stretch of 2. We do technically have a y-intercept of 0 down 6, good. And then remember you have to set them each equal to 0. Or just take the opposite sign. And that's to find the, so we have our factored form, y equals 2 times x minus 1, x plus 3. Couldn't help myself helping you guys there, because I care about you. So we add 1 to the other side, so we get x equals 1, 0 for the x-intercept. We minus 3 to the other side, and we get x equals negative 3, 0. Way-oh! Is it going up or down? Well, it's a positive in front. Positive in front means that we're going up. Way-oh! Okay, there we go. Okay, Mr. Williams. I'm going to have to pause on this one because I've worked out this one, but I'm not sure. I need to double check for sure. So be right back. I'm just going to pause. It might be 10 minutes, but for you, it'll be 1 second. Whoa, travel through time. Whoa, that was more than 10 minutes, but you traveled through time because now you're already here where I left off. All right, so this one was, it's because I need to teach it to you still, which is probably next time, or maybe I already did teach it to you. But it's the first time I'm teaching it this year, so I remember how to do area problems and optimization problems. Mr. William wants to fence in this rectangle with 3 fenced-off congruent sections. Right? So how many widths do we have? 1, 2, 3, 4 of them. And then how many? So we have 4. So we have 4 widths. And then how many lengths do we have? We have 1. Let's do it in red. So we have 2 lengths. So we're going to say 4W for 4 of the widths and 2 of the lengths. Okay. Well, what's the total perimeter they give us, right? Because that's what perimeter is. So that's perimeter. And our total perimeter they give us is, he wants to fence in the rectangular area of his field using 1,400 feet of fencing. So that's 1,400 feet, right? So define the function LW to represent the length of the field as a function of width. So basically we want to solve for L, right? Solve for the length. So if we first go ahead and do what? Looks like they're all divisible by 2. So let's go ahead and divide by 2 all the way across. So then we get 700 is equal to 2W, because 4 divided by 2 is 2. 1,400 divided by 2 is 700. And there's your L. And now we're just going to minus 2W to the other side. Way-oh! And so we're going to kind of rewrite that so that we have the L first. So we do have 700 minus 2W equals L. Blood, you can switch that around. It's okay to switch it around. So the L is going to go first. Then the negative 2W next. I guess that should be, L first. I guess this should be lowercase. I don't know if it really matters. I don't know, but so there's our L, and then don't forget your 700, Newbold. So we move that there because you should always put the variable term first and then the constant. Whoa, done. Define the function AW to represent the area of the field as a function of width. Well, do you remember?